Lesson 22, Getting the Job Done, Speed, Work, and Measurement Units. We are on page 113. So our classwork, if an object is moving at a constant rate of speed for a certain amount of time, it is possible to find how far the object went by multiplying the rate and the time. In mathematical language, we say distance equals the rate times the time. So for example, like a rate of movement would be a car going 50 miles per hour, where you know you're going 50 miles for every 1 hour. So example 1, we're going to use the idea of a walker who went, I'm going to say distance is D. Our walker went 50 feet, and it took them a time, T, of 10.2 seconds. So we want to know what was their rate of speed. How many feet did they go per second? So this is like a car's speed, but now we have just somebody walking. Normally you'd have miles per hour because those are larger units, but we have smaller units for somebody going a little slower. So we use the equation distance equals rate times time, and we can substitute those words for variables. So we just say D equals R times T. So I can replace distance is D with 50 feet. We don't know our rate, so we keep that as an R. And we know our T is 10.2 seconds. So we have to think 50 feet is the same as what times 10.2? Well, we know that when we try and think what times something, that means we have to do the opposite and divide. So what we really want to do is we really want to say 50 feet divided by 10.2 seconds is the same as R. So if we have distance, so sorry, that's not even close to spelled right. Distance equals our rate times our time. If we want to know the rate, we can say, well, we'll take the distance divided by the time equals our rate, because we can just do the opposite operation to undo it. So this is what you'll use a lot. Distance over time, D over T, equals your rate. So I would have that written down, and I would know both of these. If we want to find the distance, you multiply the rate times the time. If you want to find the rate, you divide the distance and the time. So here, we want to find the rate. So we're dividing 50 divided by 10.2. And you can use your calculators here. And if I divide 50 by 10.2, I get 4.901960784 feet per second is my rate. And we can generally round here. I'm going to round to the tenths place. To round to the tenths place, I look at the hundredths. It's a 0, so it's less than 5, so I keep my tenth the same. I end up with R equals 4.9 feet per second. Make sure whenever you find a rate, you have 2 units, like we talked about the last couple lessons. A rate has 2 units. That's called the rate unit. And here we measured feet per second. So our hint, consider the units that you want to end up with. So if you want to end up with a rate of feet per second, then you want to divide feet by seconds. So whenever you're not sure, think, what am I ending up with? Well, my rate is feet per second, so I should divide feet by seconds. So similarly, we now have a runner. They went the same distance of 50 feet, but now their time was quicker because they ran it, and they did this in 5.1 seconds. So pause the video, and I want you to find the rate, come back for the answer, to round to the nearest tenth. Go ahead and pause it and come back. So you should have done my distance divided my time equals my rate. So 50 feet divided by 5.1 seconds equals my rate. And you should get that was the last answer. you should get 9.803921569 feet per second. And we are rounding to the nearest tenth. This is a 0, so I keep it the same. So your answer should be 9.8 feet per second is my rate. Example 2, part 1. Chris Johnson ran the 40-yard dash in 4.24 seconds. What is the rate of speed? Round any answer to the nearest hundredth. Pause the video right now, try it on your own, and then come back to check your answer. So if we want the rate of speed, we know we want to answer our rate equals the distance divided by the time. Well, I know my distance here is 40 yards. Be careful with our units, don't forget about them. And our time is 4.24 seconds. So I need to take my distance divided by my time to get my rate. So I take 40 yards divided by 4.24 seconds. And I get 9.4339. Oh, so sorry. And it keeps going. But remember, they told us to round to the nearest hundredth, tenth, hundredth. So if I'm rounding to the nearest hundredth, I look at the thousandths place. That's smaller than 5, so I keep my 3 the same. So I get my rate is 9.43 yards per second, because that's what I divided here. So make sure you have the units correct, yards per second. Part 2, in lesson 21, we converted units of measure using unit rates. If the runner were able to run at a constant rate, how many yards would he run in an hour? This problem can be solved by breaking it down into 2 steps. You're not going to work with a partner. Make a record of your calculations. Okay, so how many yards would he run in 1 minute? Well, remember, we had per second. There's 60 seconds per 1 minute. So we can take his 9.43 yards per minute, or second, I'm sorry, and we can multiply that to convert. Remember last lesson we multiplied to convert 60 seconds for every 1 minute. So I'm just multiplying by my rate of conversion, which is 60 seconds per minute. And if you notice, my seconds units cancel because they're in the numerators and denominator. I get 9.43 times 60 in my numerator, which is 565.8. I get 1 times 1 in my denominator, so I don't need to write that. And then notice I'm left with units of yards in my numerator per minute in my denominator. So now we found how many yards per minute he runs. But we want to know per hour. Remember, there's 60 minutes in 1 hour. So we take our yards per minute and multiply that by 60 minutes per 1 hour. Again, my minutes cancel because one's in the numerator, one's in the denominator. 565.8 times 60 is 33,948, and we're left with yards per hour. So that's our final answer. We completed that problem in 2 separate steps, but it is possible to complete the same problem in 1 step. We can multiply the yards per second by the yards per minute, then the minutes per hour. Okay, so we had 9.43 yards per second. And then notice in letter A, we multiplied by 60 seconds per minute. And then in letter B, we multiplied by 60 minutes per hour. But instead of doing it all separately, we can just do it all at the same time and say, well, 9.43 times 60 times 60. Do that in your calculator. You will get the same answer of 33,948 yards in 1 hour. So what you need to do is cross out the units that are both in the numerator and denominator that are in the expression because these cancel out. So seconds cancel, minutes cancel, we're left with yards per hour. So part 3, how many miles did the runner travel in that hour? Round your response to the nearest tenth. Well, remember from page 111, you can use that conversion chart, and we know there's 1 mile for every 1,760 yards. So we know we have 33,948 yards in 1 hour. And we can multiply that by 1 mile for 1,760 yards. Because notice now my yards cancel because they're in the numerator and denominator. When we multiply fractions, you multiply the numerators. So I'll take 33,948 times 1, and I get 33,948. And then I have miles in the numerator because that's still left over. I multiply my denominators together. 1 times 1,760 is 1,760. And I have hours in the denominator. And now if you notice, we have this fraction line, which really means division. So I do 33,948 divided by 1,760 on my calculator, and I get 19.3 miles per hour, because those are my units here, miles per hour. Okay, so what I want you to do is pause the video and try page 115 on your own right now, and then come back for the answers. Try 115 and then come back for the answers. So exercise 1, I drove my car on cruise control at 65 miles per hour for 3 hours without stopping. How far did I go? So now we're looking for a distance. You just multiply 65 miles per hour times our 3 hours. Cross out any units that are in both the numerator and denominator. They cancel. And we get 65 times 3. You could have used a calculator. You should get 195 miles. Exercise 2. On the road trip, the speed limit changed to 50 miles per hour in a construction zone. Traffic moved along at a constant rate of 50 miles per hour, and it took me 15 minutes or 0.25 hours to get through the zone. So notice this is already converted for you because we know that there's 1 hour is 60 minutes. So we can take 15 minutes times 1 hour over 60 minutes. Minutes cancel. We get 15 60th hours, which reduces to 1/4 hours, which is the same as 0.25 hours. So that was converted for you. Now, what is the distance of the construction zone? Well, we take our 50 miles per hour, that's our rate, times our hours, which is 0.25 hours, and 50 times 0.25, we get a distance of 12.5 miles.